Hello, everyone, and thank you for joining today's webinar, Setting SLOs and SLIs in the Real World. My name is Wing Sung, and I have the pleasure of being your moderator for today's webinar. Before we get started, I'd like to review a few housekeeping items. First, today's webinar will be recorded, and we will send it to you within 24 hours, and so you can share with your broader team that couldn't attend today. Secondly, there will be a live Q&A session at the end of the webinar, so please submit any questions you might have in the GoToWebinar control panel. And lastly, there will be a brief survey at the end of the webinar, so please take the time and give us your feedback. We always love to hear from you. And speaking today, we have Elisa Bennett, Senior Engineering Manager in the Site Reliability team here at New Relic. Her group focuses on helping teams measure and achieve their reliability goals, improving reliability for both the engineers within our company and for New Relic's customers. And without further ado, I will pass it off to Elisa.
Thank you, Wing. Good morning, everybody. As Wing said, I'm Elisa Bennett, and I lead the Site Reliability Awareness and Reliability Fitness teams at New Relic. And we're here today to talk about SLIs and SLOs in the real world. Now, the idea that SLIs and SLOs are a critical part of a high-functioning SRE and reliability practice probably isn't news to everyone here. But when you're looking at an actual in-production, complex software platform, it can be hard to figure out how to actually put SLIs and SLOs into practice, both figuring out what you should be measuring and how you measure it. So today, I'm going to share with you some concrete, practical examples of how you can define and measure SLIs and SLOs in the context of a complex modern software environment. So I believe that these are going to be useful templates that you can take home and apply to your own environment. So before we dive in, one quick disclaimer. I work at New Relic, and we drink our own champagne here. So that means we use New Relic to monitor our platform. So you're going to see some New Relic screenshots, but even though that's the example that we're sharing here today, the principles I'm talking about apply fairly universally, regardless of what tools you're using. Just making sure that we're using all of our terminology the same way, I'll do a quick refresher. So the SLIs, SLOs, and SLAs are X should be true, Y portion of the time, or else. So in this talk, I'm going to be discussing both SLIs and SLOs, but the main focus is going to be on the SLIs because until you have service level indicators, you don't actually have a place to begin measuring your service level objectives. So for example, my SLI, SLO, and SLA for this talk could be 10 key takeaways about SLIs delivered in 25 minutes or less, 99% of the time. Or I'll mail you a Wookiee. And I might have electronic Wookiees. There might be some Wookiees. We'll see. So I also want to discuss, before we dive in further, why SLIs and SLOs really matter. So some people think about SLOs as a way of grading teams. That is definitely not what they're for. This is a surefire way to create organizational resistance and a culture of blame. Some people also think about SLIs as a way to monitor and alert on things. And again, no, you should definitely have appropriate monitoring and alerting in place, but that's not the real intent of your SLIs. Instead, SLIs and SLOs exist to help engineers, teams, and their organizations make better decisions. Whether or not a system is meeting its SLO is a critical data point for teams when they're thinking about how much risk they can take on or how fast they can move. The SLO of a system is also important information for other engineers, so they know what kinds of assumptions are safe to make about that system that they're using as a dependency. And then finally, that same information is very important for the engineering organization as a whole when they're making decisions about investment levels, balancing the reliability work versus velocity on product roadmaps. Now, in this talk, I'll use the example of a SaaS monitoring product based on a simplified version of the New Relic platform. Let's call it Relic. Our top level SLI and SLO might be that the system is available if data is being received from our customers, and those customers can log in and view their data. Now that we have our top-level SLI and SLO, it's time to begin implementing different parts of measurement so we can understand how we're performing against these goals. Now, we want to identify hotspots within our platform. When we look under the hood of this product, though, there's a lot of different components. We have DBs, LBs, services, message buses, and so on. It can be really scary, the amount of complexity that we're dealing with. So where do we start? To answer that, I'm going to introduce another piece of terminology, which is the idea of a system boundary. So system boundaries are a way to think about your systems from a customer perspective. It's the point where groups of components expose one or more capabilities to your external customers. And external customers can be other teams within your organization or actual external customers. So here, for example, we have our login service, which exposes an API representing the capability to authenticate a set of credentials. Now, internally, the service has a bunch of different components. It has some service nodes, a database, maybe a read replica, and a load balancing tier. And there may be contracts between those different components of the service, but those don't actually represent a service boundary because we're not exposing the database itself or individual service nodes themselves to our external customers. Instead, it's the group of components as a whole that act in concert to provide the capability to customers of the service. And of course, those customers, as I stated, can be other systems and teams in the same org or external customers. So using this idea of system boundaries, we can group the components that deliver the product into logical units. We have a couple of systems that are made up of service instances and their backing databases, one that's made up of ingest services and Kafka pipelines, and one that's made up of UI services. And here at New Relic, system boundaries tend to line up nicely with team boundaries, which also makes it easier to draw this kind of map. Of course, we do have one more system boundary, and that's the boundary between the overall product and its external customers, the end users. And it's at this point of system boundaries where we expose capabilities to other systems or external customers, and where we want to focus most on SLIs and SLOs. Now that's because boundary SLIs and SLOs are the most highly leveraged. They're useful in to both the engineers maintaining that system and the customers of the system, and also to the business decision makers. Of course, if I'm an engineer on a team, I do care about how my individual databases are performing. But if I'm a customer of the service, I really don't care how many times the underlying database is failed over, as long as the service remains available to me. So what I want to know is how much caching, retry logic, or resilience I might need to build in around that dependency. That's what the system boundary SLO gives me. And then finally, the same information is important to engineering organizations when they're trying to make their decisions about investment levels, as I mentioned earlier. So overall, our process is going to be a fairly straightforward recipe. First, we're going to identify system boundaries that exist in the platform. We'll identify the customer-facing capabilities that exist at each system boundary. Then we'll articulate a plain English definition of what it means for that capability to be available. Then we'll define one or more SLIs corresponding to that definition, and then we'll begin to measure those SLIs. Defining an SLO for each capability comes after we've been measuring our SLIs for a while, and then we can start tracking how we're doing against it. So start measuring to get a baseline. And then we'll define those SLO targets. We'll establish what the SLO number should be based on what we're seeing and what we want to achieve. And we have one SLO per SLI or capability. And then we rinse and repeat, like iterate to refine the system with particular focus on tuning those SLO numbers over time. So hopefully that sounds like a fairly straightforward recipe. Let's try it out. Now, we have our system boundaries established, so we can start digging in under the hood. Going back to our original definition of availability for the overall platform, part of being available means we can properly ingest customer data. So that's going to be the key thing we look at for measuring the availability of our ingest tier. What this tier does is accepts incoming data from customers and then sends it hopefully to the right place so that other systems can consume it. So breaking this down, we can see that this system offers two distinct capabilities, ingest and routing. And we're going to have at least one SLI defined for each of those capabilities. Now for our data ingest capability, we want to be able to say something like X% of well-formed payloads are accepted. So here we may want to monitor the percent of incoming messages that return a 200 response. Since the ingest tier is a set of asynchronous non-transactional services, we don't really need to worry much about the response time. For data routing, however, we do want to be able to say that Y% of incoming messages are available in the correct queue for consuming systems to read within some Z seconds. So in this case, we're going to care about latency, and we can measure that by comparing the ingest timestamp for each incoming message to the time when we could actually read that message out of our message bus. Now, we do also have an SLO for each capability, and we worry less about the numbers in each of those service level indicators, SLOs, in this case, the acceptable latency, than we do about the SLIs themselves, because SLO numbers are easier to adjust down the road. And in fact, we may want to deliberately increase or decrease SLO numbers for a particular system for various business reasons. So for example, if you have a less mature system, you may want to start with a lower SLO and then increase the degree of availability that you're looking for over time. Now, if you have sharp eyes, you probably noticed that there weren't any traffic or load thresholds defined in those SLIs and SLOs, which I realize can be really, really scary if you're an engineer. But the reality of most platforms is that workload is a moving target. And so if you're lucky, it's going to generally increase over time. If you define a set of SLIs and SLOs around static workload thresholds, that just means those numbers are immediately going to get out of date. And then that in turn creates more work as you have to renegotiate them and adds frustration as people's assumptions get dropped on the floor. So I've been talking about SLO numbers and how they're relatively easy to adjust, which is true, but that doesn't mean you should just pick any number at random. Remember, we want to define and measure first before we establish an SLO. A few key things to consider when you're choosing those SLO targets include that your SLOs need to represent what the team can actually commit to supporting, and they need to be based in technical realities. There's no point in having an SLO that a team is going to consistently miss and views as unrealistic. It's going to be really terrible for morale, plus SLOs are how other teams are going to reason about the system. The same is true for organizational commitment to SLOs. SLOs should be a tool to create organizational alignment. You can't have major disagreement between leaders and engineers about what the SLO should be. Defining a set of SLIs and SLOs implies a commitment on the part of both engineering teams and organizations to invest in the work to defend those SLOs over time as workloads change. So that either means figuring out programmatic ways to manage workload like API keys and rate limits, or doing the scaling work to keep SLOs true as your workloads increase. We really want engineers to view SLIs and SLOs as a tool that can actually help their teams clarify priorities by clearly surfacing what kinds of scaling or other reliability work needs to happen. So again, we generally try to define and measure first, then establish an SLO. That's a common theme through this webinar. Okay, so after data ingest, one of the next key things that happens is that data gets stored in our main data tier systems, which at New Relic is our proprietary database that we call NRDB. Now, going back to the top level definition, customers being able to use their data, meaning store it and view it, this is a key part of what it means for us to be available. And so that translates into two distinct capabilities, the ability to insert data and the ability to query data. And those are going to be the focus here. Under the hood, NRDB is a massive beast. It's a big distributed system with thousands of nodes and different worker types. Under the hood, we're going to monitor and care about specific metrics like memory usage and GC time, data durability and availability, events scanned per second. But at the level of the system boundary, we can really just look at insert latency and query response times as proxies for all of those classes of underlying error. So for our query capability, the SLIs we're going to care about are error rate and response time. Now, of course, we talk about setting an SLI for response times. When we talk about this, we're not going to look at averages because averages lie. We also don't want to look at the 99.9th percentile, for example, because that's going to be a pathological case or pathological cases. Instead, we tend to focus on the 95th or the 99th percentile, since that gives us insight into the experience of more of our customers. And we're instrumenting our queries, so it's easy to slide this around. And then there's a nifty trick here. We're going to configure an alert condition to trigger if we go over our 99th percentile SLI. Now, we don't necessarily want to get woken up for this. We would probably set a less sensitive threshold for waking somebody up. But now we can actually look at the times that we're in violation of this alert condition to compute how often we're satisfying this SLI. And then we're going to do the same thing for our insert capability SLI. Now, using these SLIs, we can articulate an SLO for each of them. Or, alternately, we can express this as a single service level objective that includes both conditions. Now, the benefit here is that it's sometimes easier for customers of the system to reason about a single compound SLO than several independent ones. And when you do this, computing the SLO becomes a matter of looking at how much of the time the system was satisfying all of its SLOs. We AND them together. Now, in addition to our new data tier, we also have some legacy systems that are hard-sharded. Yes, it's true. We're working to get rid of cases like these, but we do need to include them in our SLIs and SLOs because they still exist and they're part of the production platform. In a lot of respects, when we think about SLIs and SLOs for these systems, it's going to look a lot like our newer horizontally scaled data tier. The specifics of how we measure SLIs are going to be a little bit different, but conceptually it's about the same. Now, the big difference here is that we're actually going to measure the SLIs and SLOs performance separately for each shard. And that's because due to the hard sharding, your users' workloads aren't distributed between the shards. So that's a very important difference between your SLIs for horizontally scaled systems and hard sharded systems. In a horizontally scaled system, if one node out of 3 goes down, then we see a 33% error rate as a result. We can anticipate, though, that all of our users are still going to have roughly 2/3 of their requests satisfied because the workload is spread evenly. So we measure the capability as it's delivered across all of the nodes. In a hard sharded system with 3 nodes, however, if you lose 1 node out of 3, then yes, statistically it is still 33% error rate across all the shards, but in reality what's happening is that some of your customers are seeing 100% error rate, while other customers are seeing no errors at all. And that's a really big difference between 1/3 of your customers being down and all of your customers being partially degraded. So in this case, we measure SLIs and SLOs separately for each logical instance of a system, in this case for each shard. And you'd also use the same strategy for a cellular architecture or multi-region architecture, where there are different logical instances with potentially different failure domains. Okay, so we've talked through defining SLIs for a bunch of different parts of our platform, but we've avoided tackling some of the most important SLIs and SLOs up until now, the ones that are for our underlying infrastructure. And in particular, our networking tier and our container scheduler and cluster, where all this stuff is running. Now, these are going to be SLOs that really matter to us because they're the foundation of everything else. And these can also be some of the most challenging places to define SLIs because the compute layer and the network is kind of like the force. It surrounds us and binds us. It's everywhere. May the force always be with us. So if we remember our simple recipe, the challenge here is to break up our networking tier into specific, well-defined capabilities. And it turns out there's one really weird trick you can use if you're in doubt about what your capabilities are. Talk to people. So this is a really important tool to use when you're defining your capabilities. Talk to your fellow engineers, your customers, and ask them what they expect from your system. What dependencies, what guarantees are they looking for? And you can look for common patterns that can then help shape your understanding of how to define those plain language specific capabilities. Now, in the case of the networking tier, we know that we have three main capabilities that we're looking for and that we care about. Load balanced endpoints that expose services internally or externally, connectivity between racks in a single AZ, and connectivity between AZs. So we'll set up an SLI for each of these capabilities. And although we can adjust our SLO numbers later, we also know that we're going to need a higher SLO here than for our services, because this is a hard dependency for those services to run. Turns out it's pretty hard to code around a network failure. Now, in general, we assume we're going to lose roughly an order of magnitude for each tier of our infrastructure in terms of uptime. So setting 99.99%, 4 nines as your goal for your SLO is a reasonable initial goal if you're looking for 99.9% or 3 nines of availability for the services that are running on your network. So before we move on, let's pause for a minute and dig into that topic. How different types of dependencies impact the overall behavior of a system. As we can see here, our platform is made up of several different tiers of dependencies. So the network is at the bottom of our dependency tree, which means that, So the network is at the bottom of our dependency tree. Everything needs the network to run. The ingest tier, on the other hand, is pretty isolated. It's not a hard dependency for anything else. If ingest blips, everything else can keep on going. And if everything else other than the network goes down, ingest can still keep running. Our data tier, on the other hand, is a dependency for our UI and service tiers, and the UI tier also relies on the service tier to run. It's at the top of our dependency graph. So let's look at a couple of different failure scenarios. So if something goes wrong with the UI tier, it's going to be isolated to that tier. And since it's isolated failure, it's likely going to be pretty easy for us to recover in most cases. If our service tier goes down, the UI is probably also going to be impacted, but we can implement some UI caching that can reduce that impact. If the data tier goes down, then that's more serious. The service tier and the UI tier also go down, and the UI isn't going to recover until both the data tier and service tier come back online. If the network tier goes down, that's going to be our worst case scenario. That means pretty much everything else is going to need some recovery time before the system is back online. And usually systems don't come back the instant a dependency recovers. So MTTR, mean time to resolution, increases for each level of the stack. It's also going to be much harder for us to implement graceful degradation scenarios against hard infrastructure outages. So this is why investing in reliability at the infrastructure layers and setting correspondingly higher SLOs is one of the best things we can do for the overall health of our platform. All right, so the next core piece of infrastructure we need to look at is our container scheduler and cluster. Along with the network, this is the most significant dependency for all of our services, since it's where everything actually runs. And basically, what we want out of the system is the ability to run jobs, in this case, Docker containers, on demand with a set of computing resources available to the job that we've requested. So this is a case where we're going to need to get a little creative about figuring out what SLIs for this plain natural language capability statement would look like. So the first criteria we need to think about is how to determine whether jobs are actually getting the resources we expect. Now, in this runtime cluster, we're using hard quotas and process isolation to allocate CPU and memory, so that sort of resource starvation should never happen. If there's not enough memory or CPU for the job, it'll never get started in the first place. Network I/O, on the other hand, isn't formally isolated, so we do need to measure this. Since we don't have great metrics on per job I/O weight, we're going to measure network throughput on the host itself, and we can assume if we get to 90% of our link speed, the link is saturated and we're not providing full availability for jobs on that host. So we can subtract that time when the link is saturated from our availability on a given host. And this is an example of an indirect measurement of availability, but one that we can identify as critical based on our natural language understanding of what we need from the system. In addition to the resources available to run a job, we also need to think about job uptime itself. And this is tricky because, again, we don't want to measure jobs that failed because of issues within the code for that job. What we actually are measuring is the potential uptime available to a job. So the trick here is going to be looking at the actual life cycle of a job, and in this case, we're using Mesos, which uses the concept of tasks. So here we see that there's a couple of states capturing a job that's been scheduled and not yet started. And there are another set of states that represent error conditions in the cluster. So we can measure the amount of time that jobs are in one of those states and say that's probably downtime introduced by the cluster rather than because of an issue with the task itself. And of course, writing a service to pull these stats from the Mesos API is some work. So here, as an approximate first step, we might also just define a synthetic script that tries to deploy a new job and measures the time to startup as an indirect proxy for all of this. Now, it's an inexact measurement, but it's also a reasonable starting point to give us some visibility into the system while we build out the more sophisticated SLI measurements. Now, moving up the stack, the next set of SLIs and SLOs we're going to want to look at are for our UI tier. Now, at this point, our definition of availability is pretty clear, pretty self-explanatory. We want to deliver a UI that's fast and error-free. But to measure that, we're going to need to change our perspective a bit. Rather than measuring what's happening on our servers, the goal here is to try to capture data about what the users themselves are experiencing, which means we're going to need to look at behavior within the browser. So, for example, we're going to care about initial page load time. Like server response time, we're going to want to look at something like the 95th or 99th percentile load time rather than the average. We may also want to set different SLIs for different geographies. But for modern web apps, page load time is only a small part of the picture. Since this is a single page app, we also want to measure the responsiveness of different interactions in the browser, like triggering AJAX actions and DOM changes. And of course, we're going to want to look at error rates both on the server and in JavaScript. We may also want to prioritize UX correctness on certain browsers more than others. At New Relic, we use the New Relic browser monitoring to track things like page load times by geography and browser interaction times by user agent. But the main point here is that properly measuring the availability of a modern UI is much more complex than simple ping times, which tend to be fairly meaningless in terms of the user experience. And ultimately, the user experience is the thing that matters the most to the business and to our customers. So we finally have SLIs and SLOs for each individual system and capability that deliver our overall platform. And it's awesome because it's going to help teams prioritize and defend the decisions around reliability work, and also help us identify hotspots where we might need to invest more in reliability. But we do still need to implement one more SLI and SLO, which is for your overall customer-facing availability of the product. And that's a sanity check to make sure that all of the components are working together in a reasonable way. Now, keep in mind the SLI for the UI, we were just looking at responsiveness and error-free delivery of the front end. We weren't looking at end-to-end correctness. So for that overall correctness check, we're going to implement a synthetic script that represents a simple end-to-end workflow of sending a piece of data to the platform, then logging in and querying for the data we expect to be present. If we see a significant discrepancy between the performance of the script and the SLO performance of individual systems, then we'll know we need to revisit our SLI methodology. All right, now we're almost done. We have our sanity check in place. We're looking at our overall platform, but there's one other important thing worth noting when we're considering the customer experience. So far, all of our SLIs and SLOs have been talking about measuring the average availability. And that does give us a really good statistical sense of how our product is performing for our customers in general. But purely statistical views into availability can disguise the fact that some of our customers can be having a far better or worse experience than average due to their particular usage profile. And it's also not unusual for business to say, we want to deliver good availability for all of our customers, but we want to deliver really good availability for our most strategic partners. So in practice, we may actually want to measure this by defining a separate SLI and SLO for each of those key customers. And ideally, this means querying your existing monitoring data for users with a specific ID. This can be easy if you're tagging your analytics events. But it can also look like building a synthetic script that checks that we're receiving data from those key customers, and we can query it back out of the system. And in fact, doing a few customer-specific measurements can be healthy since, as I mentioned, experiences can vary based on the usage profile. But the big caution here is that in general, it's a bad idea to set SLIs and SLOs for a large number of individual customers because it does introduce a lot of noise into the signal that your engineers and teams are trying to use to make their reliability decisions. All right, let's recap. So first, worry more about SLIs than SLOs. Start with plain English descriptions of availability, not with the technical underpinnings. Define your SLIs and SLOs for specific capabilities at system boundaries. Each logical instance of a system gets its own SLO. SLIs are not the same as alerts. Do not page on them. And together, SLIs for a given capability into a single SLO for that capability. Write down your SLI, SLO contracts and share them. Key customers may actually need their own SLOs and SLIs. Assume your SLOs and SLIs will both evolve over time. And finally, SLOs represent an ongoing commitment. All right, so how did I do with my SLI, SLO, SLA? I think I blew it. This was actually scheduled to be a 30-minute webinar, so I said my delivery objective was 25 minutes. So you all get Wookiees, maybe electronic Wookiees.
Excellent. Thank you, Elisa, for the wonderful presentation. And I want to give everyone a few moments to submit your questions. If you haven't already, you may do so by submitting on the GoToWebinar control panel. And before we go into Q&A, I just want to let everyone know that this is our last episode in our DevOps webinar series. And if you want to catch an on-demand version of the previous webinars, you may do so by visiting newrelic.com/webinars, which is on the screen right now. And if you're interested to learn more about this topic, please visit this page on the screen. Yep, newrelic.com/DevOps, and there are additional resources on how New Relic can help you in your DevOps journey. Okay, so now it's time to address your questions. This is a really good one. So where does quality assurance fit into the SLI and SLO definition?
That is a good question. Here at New Relic, our teams are available for their own testing and quality assurance. We don't formally have QA engineers. But what we work with our product managers and engineering leadership to define what the acceptable levels are. And so establishing SLOs would also include that, especially in areas like our agent teams, where we're delivering things that can impact our customer sites. We don't have SLOs in the same way for agent teams. So QA is heavily involved in the quality measurements, but we don't formally set SLIs and SLOs for them.
Excellent. And another question, who sets SLOs and SLIs at New Relic? Is it the individual contributors or is it leadership?
Good question. So when we originally rolled out our service level objectives, we started at the engineering leadership executive level to gain their buy-in, because we didn't actually formally have SLIs and SLOs defined organizationally. Each team was responsible for their own, so to speak. And then from there, we went down to the manager and team level, but we did all roll out a standard service level objective goal because we offer our customers a 99.8 or above in most cases. We established an initial SLO of 99.9. And since our initial rollout of those, that's been quite a while, we have increased the SLOs for the various infrastructure, platform, and product teams is how we define them. And it's been a partnership between product management and engineering leadership, as well as the individual team members.
And a follow-up question to that is, what tools do you use to track how you actually perform at delivering on your SLOs over time?
So that's actually a great question too, because we have internal tooling that we've built. And so we have SLOs that are tracked based on our actual incidents that occur, which is both manual and programmatic. And then we've recently put a programmatic framework into place that is an internal tool. We're leveraging part of our alerting platform as far as setting alerts through our alerting product, but we don't actually page anybody on them. So it's an internally built system. And the other, we surface that information in a variety of ways through both email reports, through our Insights product, and various other amplification plans within New Relic.
Excellent. And I think that wraps up our webinar. So before you leave, please take a moment to complete the survey. And thank you so much once again to Elisa for sharing her insights and expertise. And thank you to all of you for joining us today. We will send out today's webinar and the slides tomorrow morning, and have a great rest of your day. And if we didn't get to address your questions, we will follow with you individually. Thank you so much once again for joining. Have a great rest of your day. Bye-bye.
Thank you.